In the previous video, we looked at the firm's optimality conditions under perfectly competitive goods and factor markets. Now I want to think about equilibrium. And in particular, I want to look at an economy where there are two goods in production, each produced by different representative firms and with different capital intensities. So good one is going to be produced with the following production function, a capital intensity of alpha, while good 2 is going to be produced with another Cobb-Douglas production function, but this time with a capital intensity of beta. And just to fix ideas, let's say that alpha is greater than beta, so good 1 is more capital intensive. Now, the optimality conditions that we derived in the previous video are going to hold for both firm 1 and firm 2. In particular, let me write out capital demand as a function of labor demand for both firms. So remember, capital demand is increasing in labor demand, it's decreasing in the relative price of capital, and it's increasing in the capital intensity. And likewise for firm 2, okay, now I'm going to assume that capital and labor are supplied with just a fixed supply. So let's call that K bar. And this equilibrium, this market clearing condition, tells us that the demand for capital in sector 1 plus the demand for capital in sector 2 must equal this fixed capital supply. And likewise for labor demand, total labor demand across both sectors must equal the fixed labor supply. Now, we can combine these two firm optimality conditions and these two market clearing conditions to allow us to derive demand for capital, for example, in sector 1, purely as a function of these exogenous supplies of capital and labor and the relative prices of capital and labor. So let's do that. Let's just substitute in K1 and K2 here into this market clearing condition for capital, and we get the following. Now I could write L2 here, but instead I'm going to rewrite this as L bar minus L1 using the market clearing condition for labor. And of course this must equal K bar. Now I can rearrange this equation to give me labor supply in sector 1, labor demand in sector 1 in terms of relative prices and the total exogenous supplies of capital and labor. And I won't walk you through the steps, but I get the following. So you should convince yourself that this is in fact correct. I'm not ruling out that I've made a slight algebra mistake here, but I think this is correct. But let's look at what this means. So alpha is bigger than beta by assumption. So good 1 is more capital intensive than labor intensive. It's more capital intensive than good 2. So this constant term outside the brackets is positive. We must note that. Secondly, labor demand in sector 1 is increasing in the relative price of capital. I can do the same thing for capital demand in good 1. And now I have that capital demand in sector 1 is increasing in the relative price of capital. So there's a negative sign here, and this is in the denominator. So if R goes up, this term goes down, and this is negative, so demand for capital in sector 1 goes up. Again, that's because good 1 is relatively more capital intensive than good 2. I can then substitute these expressions for capital and labor demand into the production function for good 1, which again, just to recall, looks like this. And I won't write it out, but I get some function of the relative price of capital and labor, as well as the exogenous supplies of capital and labor. I can do the same thing for good 2, and I get that the supply of labor is some other function of the relative price of capital and the exogenous supplies of labor and capital. And these two expressions and these 4 factor demands for labor and capital in sectors 1 and 2, I've just derived from combining these 4 equations for relative capital demand for both sectors and the market clearing conditions for both sectors, or for both factors, I should say, in different ways. And you should experiment a little bit and see if you can figure out how I've combined those to derive these expressions. I can also use the expression we derived for prices. So remember, in the previous video, we said that the price of good G is equal to the following function of wages and the return on capital. Now this holds in both sectors 1 and 2, but of course, by assumption, the interest rate and the wage are the same for both sectors. So if I divide the price of good 1 with the price of good 2, I should get the following result. Now this tells us that the price of good 1 relative to the price of good 2 is increasing in the price of capital relative to the price of labor. Increasing because, again, alpha by assumption is greater than beta. So this tells us that if capital is relatively more expensive, it is because, or it results in, the price of good 1, which is the more capital intensive good, being higher than the price of good 2. So now that I have this expression that relates the relative factor prices with the relative goods prices, I can then derive a second equation for the total supply of good 1 and total supply of good 2, which I'll call, let's call it F hat, which is just a function of P1, P2, and again the supplies of capital and labor. And likewise for good 2, I'll get a function G hat, again as a function of relative goods prices. And it's at this point we can start to think about general equilibrium, because now we have an expression for relative supply. I can just divide this Q1 by Q2, which is going to give me some other function, I'll call it H, which is again a function of the relative price of good 1 and good 2 and these exogenous factor supplies. And thinking back to our consumer optimization problem, we had that the demand, the relative demand for good 1 to good 2 is equal to a function of the relative price. So now using the market clearing condition in goods markets that X1 is equal to Q1 and X2 is equal to Q2. In other words, the supply and demand for each consumption good is equal in both sectors. I can use these two expressions, which again I haven't derived for supply because it's a really complicated expression and it's not particularly enlightening. I can combine these to find the equilibrium relative price and the equilibrium relative quantity. And this is exactly what I've done here. So you can see the relative demand curve in blue here, which I've taken from the previous video, and the relative supply curve, so Q1 over Q2, is the curve in red. And we can find our equilibrium, of course, with the intersection of the two curves, which is at 1, 1. Now, the slope of the relative supply curve is determined by the relative factor intensity. So I said here that alpha is greater than beta. If alpha were very close to beta, this relative supply curve would in fact be very flat. We'd have a very elastic relative supply curve. That's because if the price of one good goes up relative to another, because the two goods are relatively similar in the amount of capital and the amount of labor that they require to produce a unit of the good, the firms producing the good with the higher price, the slightly higher price, will now produce considerably more because they get a higher price, but they require essentially the same amount of each good, each factor. Conversely, if the factor intensities were very different, the supply curve would be very steep. In addition, changes in the relative supplies of the different factors are going to shift up and down the relative supply curve. So for example, we said here that good 1 is the more capital intensive good, alpha is greater than beta. So in this case, an increase in the supply of capital, K bar, would shift down the relative supply curve. That's because an increase in the price of capital is going to incentivize production of the capital intensive good, which happens to be good 1. Likewise, an increase in the supply of labor will shift up the relative supply curve because that will incentivize the supply of the labor intensive good, which is good 2. Okay, that's it for this video. Thanks very much, and I'll see you in the next one.